Hey guys, welcome to DSP NIT Andhra. I am Sai Chandra from ECE department. Today we are going to discuss about frequency transformation of bandpass and bandstop filters in analog domain. We can design an IIR filter using analog low-pass filter by applying frequency transformation. Transformation can be applied in two ways. One is to convert the analog low-pass filter into the required analog filter, and using frequency transformation we can convert into digital filter. Another method is to convert the analog low-pass filter into digital low-pass filter using Z transform and then applying frequency transformation to the required digital filter. We can convert a low-pass filter into band-pass filter by the following method. First, we have to transform S into omega p into S square plus omega L into omega u by S into omega u minus omega L, where omega p is the band-pass frequency of the low-pass filter. Omega L is the lower band edge frequency of the band-pass filter. Omega u is the upper band frequency of the bandpass filter. Then we have to substitute the value of S in the frequency response of the low pass filter. We can verify the above equation by substituting different values of S. For example, when S equal to 0, the gain of the low pass filter is infinite. For the bandpass filter's gain to be infinite, the value of S should be plus or minus root over j into omega u into omega L. This value can be seen here. For the gain of the bandpass filter to be 0, S equal to 0 or infinite, which can be seen here. Similarly, we can convert low pass to band stop filter by converting S into omega p into S into omega u minus omega L by S square plus omega u into omega L. Then we have to substitute the value of S into the frequency response of the low pass filter. We can see here that when S equal to plus or minus j root omega u into omega L, the frequency response of the band stop filter is 0. Similarly, when S equal to 0 and infinity, the frequency response of the bandstop filter is infinite, which can be seen in this graph. Now we'll do an example. Here a single pole low pass filter is given with the impulse response of 1 by S plus 1 and passband edge frequency of 10 radians per second. We need to transform this low pass filter into band pass filter with lower cutoff frequency 10 radians per second, upper cutoff frequency 40 radians per second, and a band stop filter with lower cutoff frequency 10 radians per second and an upper cutoff frequency of 40 radians per second. From the question we can see that omega u equal to 40 radians per second, omega L equal to 10 radians per second, and omega p is 10 radians per second. From this we can calculate omega naught, which is a central frequency, which we get as 20 radians per second. First we'll solve for bandpass filter. We should convert S to omega p into S square plus omega u into omega L by S into omega u minus omega L. Then we have to substitute in the frequency response, which can be seen here. After substituting all the values and simplifying, we get this equation. This is the frequency response of bandpass filter. Now we can see the frequency response of low pass filter and the corresponding band pass filter which you have transformed. In the next part, we can transform S into omega p into S into omega u minus omega L by S square plus omega u into omega L to get the band stop filter. Then we have to substitute this S value in the frequency response of low pass filter. Upon substituting the values and simplifying the equation, we get this following frequency response of bandstop filter. This is a graph of bandstop filter. Here we get central frequency omega naught equal to 20 radians per second. Thank you.